Well, hello and welcome to this video on matching graphs with equations or to equations. It is an examination question. It's a GCSE higher tier, which is equivalent to 10th grade maths. Right, now the original question has not got any scales or divisions in it, so I've included scales or divisions to help me to explain. Now the question is asking us to match these graphs to these equations here. Now I've done the divisions and I've assumed that k is equal to 1. I should try and explain. The most familiar of these graphs or these equations, the most familiar is graph B, which is a straight line, and generally the equation of a straight line is of the form y is equal to mx plus c. Now in this case, the straight line passes through the point 0, 0, which then means that c has got the value of 0. And besides, it seems to me that this straight line here sort of bisects the angle of 90 degrees. So if x got a value, if x has a value, y has got the same value. For instance, if we say x is 4, y is 4, and if x is 1, y is 1. So we can comfortably say that graph B here matches equation y is equal to kx, which is this one here, and that's what we got. Now for equation y is equal to k over x, it's saying to us that when x increases here, y will decrease, and conversely, when y decreases, x will increase. And that's what we got in graph D. For instance, when x is 1, y is 1. When x is 2, the inverse of 2 is a half. Or when y is a quarter, the inverse of a quarter is 4. So we can see clearly then that when x increases, y decreases, or when x decreases, y increases. So we can now match equation y is equal to k over x to graph D. So this and that equation will match. Right, now for graphs A and C, if we say that when y is 4, x will be the square root of 4, or which is 2, or in other words, if you square 2, you get 4. And when x is 1, if you square 1, you get 1. So something else, when you have a graph of this form here, it suggests to us that the graph will be symmetrical about the y-axis. So what you've actually got, which is not actually shown in the question, is this sort of graph here, because that graph will then be symmetrical above the y-axis. So you can say then that graph A will match equation k is equal to x squared. Now for graph C, we can match that to equation y is equal to k times the square root of x, purely by elimination. But there is something else. When x is 4, square root of 4 is 2. When x is 1, square root of 1 is 1. There's something else though. If we square this equation here, I know we're not asked to do that, but if we square this equation, you have that y squared is equal to kx. And when you have an equation of the form of y squared is equal to kx, you can assume that the graph will be symmetrical about the x-axis. Okay, now compare that with when y is equal to x squared, where the graph is symmetrical above the y-axis. In this case, when y squared is equal to x, the graph will be symmetrical about the x-axis, and that's what you got there. So you can comfortably mark equation y is equal to k square root of x to graph C. I hope all that made sense, and please subscribe, and thank you for watching. Bye bye now.